Hi, and welcome to the second part of me building a CNC router. In this part, I will cover the electronics. Since I need to get this machine up and running as soon as possible, I decided to screw everything directly into a piece of wood I had laying around. I will revisit the electronics at some point, but for now, this will have to do. For power, I used the 24 volts 15 amp power supply for the stepper motors and the 48 volts 10 amp power supply for the spindle. Wiring the spindle was just a matter of following the manufacturer's instructions, but for the stepper motors it is a little bit more complicated. To control the stepper motors I am using TB6600 stepper motor drivers in combination with an Arduino and a CNC shield. With a CNC shield like this you would normally use something like an A4988 driver and just plug it in, but I am not gonna do that. So how do you connect this to this? If you take a closer look at the stepper motor driver, you can see a high voltage and a signal side. The high voltage side is relatively simple. You have your supply voltage, in my case it is 24 volts, and the connection for the 4 stepper motor leads. The signal side is a bit more complicated, but I will go through that one by one. First, I connect all the negative signals together. This will be our common ground. Then I attach a wire to each of the positive signals. This leaves us with 4 wires: enable, direction, pulse and ground. The ground wire can be connected to any ground point on the shield. I chose the screw terminals as it was the easiest. As for the others, I connected them to where you would normally plug in a smaller stepper motor driver. Enable gets connected to the enable pin on the shield, which is the first in the left row. Direction gets connected to the direction pin, which is the last, and pulse gets connected to the step pin on the shield. If you are unsure which pins that are, you can take a look at the underside of such a stepper driver. They are often bundled with the CNC shield. Before I continue, I should mention that building this will require you to work with mains AC voltage, which is dangerous, so don't do this if you don't know what you are doing. The way I build it is especially dangerous since there's exposed mains voltage in some parts, and I'm already working on fixing that. I've also updated the Thingiverse site to include all the STL files that you will see in this video, but please don't just do everything without care and make sure that what you build is safe. Now with that out of the way, let's get to building. Because I didn't have enough wire to wire up all the end stops, I ended up having two cables, one for the 3 signals and one for power. The end stops have actually not been enabled in software because I couldn't get it working in time. One thing I've definitely learned is that you need way more wire than you think. I thought I'd way too much, but in the end it wasn't enough. With that, the hardware is pretty much complete. The only thing missing is the software. I need two different kinds of programs. The PC needs software that can send G-codes to our Arduino, thereby telling it how to move, and the Arduino needs a program to interpret these commands and control the stepper motors. For the Arduino, I used GRBL. To install it, I went to the GitHub page, the link is in the description, and downloaded the latest version. I extracted it and edited the GRBL folder to my Arduino libraries. After that, I opened the sample script and uploaded it to the Arduino. For the PC, I used CNC.js, which has a ton of options for controlling a CNC machine. Depending on which kind of operating system you are on, you will need to install a different version. After the installation was complete, I connected to the Arduino and attempted to move the machine. You may have noticed one of two problems. For one, I wanted the machine to move to the left. Fixing this is relatively easy. I just had to swap the polarity of one of the coils for the motor. The other issue is that I told the machine to move 100 mm. To fix this, I had to tell the machine how many steps the motor needs to take to move by 1 mm. After a bit of trial and error, I ended up with 800 for the X and Y axis and 2400 for the Z axis. This can be written to the Arduino using these 3 commands. I later also increased the hop speed and acceleration. Another thing I had to make sure was to have both Y-axis motors move together. There is a way to achieve this in software, but for some reason it wouldn't work for me. So I decided to use these jumpers to make the second stepper motor mirror the first. This is definitely not the best solution, as using software allows for some pretty useful features. Now the machine can move in all directions, but there's one last thing to do. This is to ensure the machine is square. I did this by telling the machine to move through the 4 corners of a 20 by 20 mm rectangle. If the machine is square, both diagonals will be the same length. Because I don't want to screw directly into my base plate, I used some tape to hold a small piece of wood in place. To my surprise, it was pretty close. I made a few adjustments to get it just perfect. However, I will do more calibrations at a later point. I will leave it at that for now. If you liked it, consider subscribing to not miss my next upload. Till next time.